Okay, we will go through the exemplar problems in class 12 chemistry chapter 8 D and F log elements. Okay, before that we will see some general information. So what is the oxidation number and how to find the oxidation number? Let us say example, if we take a element X with atomic number of 20, and if we say X2 plus, that means it lost 2 electrons. Lost 2 electrons, that means losing electron means oxidation. X2 minus means it gained 2 electron, that means reduction. So the oxidation and reduction. Okay, losing electron is oxidation, gaining electron is a reduction. Okay, how to find the oxidation number of the various elements? Neutral elements are 0, like here zinc is 0, Cl2 0, but if it is a charge, then it will be single charge, it will be equal to 3 plus means plus 3, 2 minus means minus 2, but it's a diatomic like He2 2 plus, then you have to divide this part by the number of atoms. So here plus 2 divided by 2 plus 1. Okay, in a compound, how to find the oxidation state? Here phosphorus, how to find? So you have to take the oxygen negative 2, then after that you will get a P equal to positive 5. So what are the rules to find the oxidation number is given in your class 11 chemistry redox reactions chapter. Okay, you have to read these oxidation rules in the class 11 chemistry redox reactions. Okay, so if you write C within copper within bracket 1 means it oxidation state plus 1, Cu within bracket 2 means plus 2. Okay, so what are the various symbols used? Delta AH means is the enthalpy of the atomization. Okay, delta A means atomization, enthalpy atomization. Delta IH, that is enthalpy of the ionization. Ionization enthalpy is nothing but the enthalpy to remove one electron from the orbital. Okay, the first electron will have the less enthalpy than the other electrons, because once the first electron come out is the most loosely bound electron only will come out first, so that will have lesser enthalpy than the other electrons. That is first enthalpy, ionization enthalpy will be less than the second ionization enthalpy, less than the third, like that. Okay, this is E minus standard electrode potential. Okay, less E minus means it is more stable. Standard electrode with less means more stable. What is amphoteric? That is the substance which can react with both acid as well as in base. It's called amphoteric. Example, water. Water can act as acid as well as base. Okay. The enthalpy of atomization is nothing but the total enthalpy to breaking all bonds between the atoms. Example, if you take CH4, CH, there are 4 bonds. Breaking all the bonds, what is the total enthalpy? So the breaking the first bond enthalpy may be less than the breaking the second bond, and the second bond will be less than the third one, because as the first bond will be the less loosely coupled bond will break the first. Okay, so it is given in per mole. Okay, this enthalpy of atomization is given per mole substance. How much enthalpy is given per mole? 1 mole. Okay, this hydration enthalpy. This is nothing but the measure of the attractive force between the ion and the water molecules in the water. Example, for Na plus ion, this many kilojoules per mole. This is also given in the per mole. Okay. Now something about how filling of the orbitals. the completely filled and or half filled orbital are more stable than the partially filled one. Example, 4s2 is stable than 4s1 because this is half filled, this is completely filled. S orbital having 2 electrons maximum. So 4s2 completely filled is more stable than this is half filled. 3d5, this half filled is more than this partially filled. D orbital 10 electrons, so here 3 electrons, this half filled 5. Half filled is more stable than this partially filled. 3d10, that is completely filled is more than the 3d5 half filled. Okay. So here in the d orbital, how it is filled, there is also a crystal field theory in the class 11 coordination compound chapter. In d orbital splitting into T2g and Eg, this is excited state Eg, T2g is ground state electron, the excited state electron. How it is split? There are rules given in that chapter. You have to go through the coordination compound chapter to understand what is this T2g and Eg. Okay. So the magnetic moment of the substance, spin only magnetic moment, is based on the unpaired electrons. N into n plus 2 square root of this is spin only magnetic moment. Okay. So we have the orbital contribution also in some of the compounds. Okay, if you take some example, some element, this is a nucleus and this is the first orbit, second orbit. Okay, see this whenever you make the ionization, electron from the outermost orbit will come out first. That will have the less ionization enthalpy. Then if you are pulling electron from here, that will be more because it is close to the nucleus. So always first ionization enthalpy is less than the second, less than the third, etc. Because as electrons come out, loosely bound only will come out first. Okay. The filling order is n, electron filling order n plus L rule. N is the principal quantum number, L is azimuthal quantum number. L is 0 for S orbital, L is 1 for the P orbital, 2 for D, 3 for F. Okay, suppose it is 3s orbital. N, principal quantum number 3s is 0. Okay, that is 3, 3. Then 4d is 4 plus 2, 6. The electronic configuration of a transition element is plus 3 oxidation state is this given. What is the atomic number? So this is given in the book. The based on that, so you have to add this argon plus this, then you will get 26. Okay, this plus 3 oxidation state. Plus 3, it already lost 3 electrons. Okay, so you have to add 3 plus this total thing, then you will get this. Okay, here, okay, 26, this is the element. So here the oxidation state 3. The electronic configuration of the copper 2 is whereas electronic configuration of the copper 1 is, which is the following is correct. So here copper 29, the atomic number. So C1, that is oxidation state of 1, means it lost 1 electron, so it is 28. These two 27. The effective charge of we have to here this effective charge we have to take into account. Okay. So here this is the outermost and this is the nucleus. So total atomic number minus between the nucleus and the outermost shell, the number of electron in this inner orbital, you have to minus it. Okay, Cu 29 atomic number 128. So the inner between the nucleus and the outer shell, we have 1s to 2s to 2p6, that is 10 electrons. For Cu1 the remaining will be 18 electron, Cu2 remaining will be 17 electron. This is more stable. Effective nuclear charge, because the nuclear charge is less effective. This is more stable than this one, because you have more electrons in the effective nuclear charge. Okay, Cu2 is more stable than the Cu1. So Cu2 is more stable than the Cu1, because the effective nuclear charge is less here. This is 118, that is 17 only. Metallic radii of the some transition elements are given. Which of the elements will have the highest density? See, the density formula is mass by volume. If you divide by this, then this will have the highest number. Okay, this number. Okay, these are the atomic numbers, and you have to divide it by this atomic mass divided by this atomic weight divided by this radius. You will get the density, mass by volume. So this will have the highest number. Generally, transition elements form the colored salts due to the presence of the unfurled electron. Which of the following will be colored in the solid state? These are the atomic numbers. Okay, you have to first find the oxidation state. Okay, oxidation state or oxidation number using the rules in the redox reaction. After finding the oxidation state, you will see that after the oxidation state you will find the electronic configuration. In that there is no unfurled electrons in this. So here you will have say unfurled electron. So this one is the colored. So here you have to write the electronic arm of the 27. C is 29, 2 plus means lost 2 electrons. So 27, you have to write the electron, it has the unfurled electron. That is why it's colored. Other things don't have the unfurled electrons, they are not colored. Addition of small amount of KN4 is concentrated H2O4 is a green only compound is obtained, which is highly explosive in nature. Identify the compound only. Okay, this is the compound. You can go through that book. The magnetic nature of the elements depends on the presence of the unpaired electrons. So the spin magnetic moment depend on the presence of the unpaired electrons. Okay, the orbital magnetic moment is not depend on only this. Only spin only magnetic moment depends on the unpaired electrons only. Identify the configuration of the transition element which has the highest. So this is the highest number of unpaired electrons. So you have to write that electron distribution in orbitals, then you will find these unpaired electrons. See here, 3d7 number of unpaired electrons is 3 only. 3d8 number of unpaired electrons 2. 3d5 we have all, none of them is paired, all unpaired electrons, 5 electrons. So these are the more unpaired electrons, 3d5. So this is the highest spin only magnetic moment. 3-5 unpaired electrons. Which of the following oxidation state is common for all lanthanides? This is +3. Okay. Here the common oxidation state of +3 lanthanides. Which of the following reactions are disproportionation reactions? That is, in this reaction there is a oxidation as well as reduction will take place. That is called a disproportionate reaction. So here if you see this is getting oxidized as well as reduced. So it's losing electron and become more positive charge, and gaining electron will become a neutral. So both oxidation and reduction takes place. That is why it is called disproportionation reactions. Okay, here also this is oxidized to this. Actually this is 2 minus, you will see in the book, and this is getting reduced here. Okay, this is after reduction, this is after oxidation. So here 2 minus, okay. So there is a typo mistake in the book. So here disproportion 2 minus here, okay. So A and B both are disproportionate reaction. Oxidation and reduction taking place in both the reactions. When KMO solution is added to oxalic acid solution, the decolorization is slow at the beginning and becomes instantaneous after some, because this is autocatalyst, okay. In between Mn4 ion is formed, then after that Mn2 plus ion is formed. So this is acting as a autocatalyst. There are 14 elements in the oxygenide series. Which of the following elements does not belong to in the book and the table it is given. So thulium, this is a lanthanide, okay. So this does not belong to this series. KMnO for oxygen in acidic medium, the number of moles of KMnO that will be required to react with 1 mole of sulfide ion, okay. The number of mole of the KMnO required to react with 1 mole of the sulfide ion they are asking, okay. For 1 mole, so there are 5 sulfide for 2 moles. So for 1 mole it will be 2 by 5 moles of the KMnO. So I will show it 20. So this one is the balanced one, okay. Here, so we have 5 moles for the 2 moles. They are asking for 1 mole, then 2 by 5. 2 by 5. Which of the following is amphoteric oxide? Amphoteric means as well as acid as well as base type, okay. 17. So here you see these two are amphoteric. Gadolinium belongs to the 4Fc, atomic number is 64. Which of the following is the correct electronic configuration? Okay, this filling of the orbital n plus n rule. Correct electronic configuration 22. See here, this is given, this is the correct electronic configuration, stable electronic configuration. Industrial compounds are formed when a small atoms are trapped inside the crystal lattice of the metal. Which of the following is not the characteristic property of this compound? Okay, they have these things are all correct, only this is wrong. Which are they are going not the characteristic 16. So this is chemically inert, okay. This is the characteristic, but they are given the ulta. Okay, they are chemically very reactive, they are saying. Inert means not reactive, okay. This is wrong, this is not. All the other things are correct. The magnetic moment associated with the spin angular momentum as well as and the orbital angular momentum. Spin and orbital angular momentum. Spin only magnetic moment value for this ion is spin only. Spin only depends on the number of unpaired electrons only. Spin only, okay. So this here is 24 atomic number. 3 means 21. There are 3 unpaired electrons, okay. Here if you apply that rule, filling rule, square root of n into n plus 2 is the spin only magnetic rule. N is 3 here. 15. So this is 21. 3 plus is 21. Minus 2 is 2, okay. Here we have the d orbital 3 electrons. So n into n is a number of unpaired electrons, 3 n into n plus 2. 3 into 3 plus 2, 5. So this is the final. Bohr magnetron is unit of the magnetic moment. Km oxidizing an alkaline solution. When alkaline Km treated with Ka, iodide ion is oxidized to this iodate ion 20. This is the iodate ion. Iodine to iodate, oxidation of iodine to iodate ion. Which of the following statement is not correct? Copper liberates hydrogen from acid. No, copper will have the less E minus, so it will not liberate. 10. See, the unique behavior of having positive electrode potential accounts for the inability to liberate. Inability to liberate. It can't liberate. So copper liberate the given. This is not correct. Other statements are correct. Okay. Which when acidified solution, this is an oxidizing agent. Solution is added to the tin. This is element name. Salt then changes to, because this is a oxidizing agent, this will oxidize to the highest oxidation state. This is the highest oxidation state of this. The highest oxidation state of manganese 4 is plus 4 in Mn4. But the highest oxidation state of plus 7 in this with oxygen, because the covalent compounds fluorine can form single bond and fluorine can form single bond, while the oxygen forms the double bond. Oxygen can form the double bond. That is why it's more oxidation state. See here. The ability of oxygen to stabilize these oxidation states exceeds that of the fluorine more than the fluorine, because the highest whereas the highest this to form the multiple bonds. Okay, with oxygen it can form multiple bonds, whereas fluorine can form only single bonds. That is why the oxidation number more here. Although this zirconium belongs to the 4D transition element and 3D transition, they are similar physical and chemical properties. Okay, they are in different series, but they have the similar physical and chemical properties because they have the similar atomic radius. 21. See here, these two elements they have similar atomic radius. Okay, that is why they have the, although they belong to different series, they have a similar atomic radius, though physical and chemical properties similar. And HCl, why HCl not used to make the medium acidic in the oxidation reactions of the KM104? Because this KM4 oxidizes HCl into Cl2, which is also a oxidizing agent. This is also oxidizing agent. This will also become an oxidizing agent. Okay, multiple choice questions. Generally, transitional elements and their salts are colored due to the presence of the unpaired electron. Which of the following compounds? Okay, and these two compounds, the color is mentioned, is given in the book. They are not because of the unpaired electron, but due to the charge transfer between the atoms. Okay, these compounds get the color. Transition elements show the magnetic moment due to spin and orbital motion of electrons. Which of the following atoms have almost same spin only? Spin only magnetic moment arises due to the unpaired electrons. So this has the three unpaired electrons. This also having three unpaired electrons. In the form of the dichromate, CaF4 is a strong oxidizing agent in acidic medium than manganese ore in Mn. Okay, not because of these two reasons. These two options, more stable than chromium 4. Higher oxidation states of heavier members of the group 6 of the transition series are more stable. Which of the following actinides have the oxidation state of +7? 24 +7 oxidation states. The see here, this is having the +7. General electronic configuration of okay, this which of the following have one electron in the 60, one electron, uranium and neptunium. 23. See here, one electron in the 60. Which of the following lanthanides show +2 oxidation state besides the characteristic oxidation state of +3? Lanthanides normally have +3. These elements have +2 oxidation state also. 21. Okay. Okay, you can go through it. Which of the following ions show higher spin only magnetic moment? Spin only magnetic moment. So which has the highest unpaired electrons. Okay, this has the highest unpaired electrons. So this will have the more spin only magnetic moment. Transition elements form binary compounds with halogens. Which of the following compounds will form these MF type compounds? These two. Which of the following will not act as oxidizing agent? Okay, these two are not oxidizing agent. They are not the oxidizing agent, these two compounds. Although +3 is a characteristic oxidation lanthanides, but cerium has a +4 oxidation state because it has a tendency to attain noble gas configuration and tendency to attain F0 configuration. Short answer type. Why does copper not replace hydrogen from acids? Positive electrode potential. Positive stand electropocation, so it will not liberate hydrogen. Why E- value for Mn, nickel and zinc are more negative than the expected? Stabilities of the off-filled and fully filled configuration respectively. Okay, these have half filled and fully filled electronic configuration. But for the nickel ENS value related to the highest negative enthalpy of the iteration. Okay, so here is E minus for the nickel and zinc more negative than the expected from the trend. Why? First, ionization enthalpy of chromium is lower than the this zinc. So the ionization enthalpy of fully filled is greater than the half filled. Okay, fully filled more stable than the half filled. So this is completely filled. This will have more than this. This is half filled and this is completely filled. 4s1 is half filled and 4s2 is completely filled. So this will have the more ionization enthalpy. Transition elements show high melting point 4. The high melting point of the metals are attributed to the involvement of the greater number of electrons from the n-2 in addition to the ns electrons. Okay, greater number of involvement from this orbital in addition to the ns orbital. When the copper treated with potassium iodide, a white precipitate is formed. Explain the reaction with the help of the chemical reaction. 36. Okay, this reaction gets reduced to copper. This is getting reduced. Okay, this is on reduction. So it is gaining electron and getting reduced to this copper white precipitate. 36. Okay, this is the reaction. Out of C to Cl to Cl, which is more stable? Why? This is the oxidation state of +2. Okay, I already told you how to find the oxidation state of the compounds. So you have to go through the redox reactions chapter in the class 11. So if based on that, this is +2 oxidation state copper. So this is more stable than this. CCl is more stable than C. The stability of the C is 2 plus, then the is due to the much more negative enthalpy. Okay. And a brown compound of manganese A is treated with the HCl, it gives the gas is taken with the anything. Okay, so 38. So this is the reaction. Although fluorine is more electronegative than oxygen, but the ability of oxygen to stabilize the higher oxidation state exceeds than fluorine. Why? The stability of oxygen to stabilize the higher oxidation state exceeds than that of the fluorine. The highest Mn fluoride, whereas the highest oxide is the ability of the oxygen to form the multiple bonds. Okay, oxygen can form multiple bonds, whereas fluorine can form only single bonds. Due to the ability of oxygen to form multiple bonds. Although Cl3 plus CO2 plus ions have the same number of unpaired electron pairs, but their magnetic moment of is less than this Y. The magnetic moment is due to spin as well as orbital contribution. Okay, so in this case. There is no orbital contribution in this case. Cr3 plus, no orbital contribution is 0. It has only spin only contribution, but this has orbital as well as spin contribution. This is based on that crystal field theory in the coordination compounds you read. So this is how the d electron is split into T2G 5 electrons, excited state, e.g. 2 electrons. Okay, so this has both unpaired as well as paired only, but this has only an unpaired electron pair. So the total magnetic moment is sum of the magnetic moment spin and orbital. So the important thing here, this has spin only and this has spin and orbital. Okay, coordination compounds chapter you read crystal field theory, how d orbital splitting taking place. Ionization enthalpy of C is higher than that of C. Okay, this is lanthanides, this is oxenides. Okay, you can go through this answer. Although ZR belongs to 4D, HF belongs to 5D transition, but it is quite difficult to separate because there is similar radius. Okay, 21. Okay, here they have similar radius, so it is difficult to separate out these two compounds. Lanthanides plus 3 is the common, but the cerium shows plus 4 oxidation state also. 25, 43. It is because after after losing the one more electron here occupies this electronic configuration, changes to the stable configuration. 43, 25. Okay, plus 4 oxygen, this attains the stable configuration. Explain why the color of the KM would disappear when oxalic acid added to the solution in the acidic medium. 44. Okay, this is color and this is colorless. Mn2 plus ion is formed. This is the reaction. This is colorless. An orange solution containing the Cr2 is treated with an alkali and yellow solution is formed. H plus ion added to the yellow solution, the orange solution is not. Explain why does this happen. 45. Dichromate to chromate, chromate to dichromate. Orange, yellow, yellow to orange. Okay. This is chromate yellow, dichromate orange, orange to yellow, yellow to orange. Okay, these reactions, one with H and one with OH. A solution of KMnO4 on reduction yields either a colorless solution or a brown precipitate or a green solution depending upon the pH of the solution. What different stages to these represent how they are carried out. 46. Acidic medium where pH is less than 7, this is the colorless Mn2 plus. Alkaline medium greater than 7 pH, green color. In the neutral medium pH equal to 7, brown precipitate. The second and the third rows of the transition element resemble each other much more than they resemble the first row. Due to the lengthened contraction, the atomic radii of the second and third row elements are almost same, so they resemble each other and much more than correspond to the first row. The cumulative effect of the contraction of the lengthened region causes the radius of series members of the third transition series to be very similar to those corresponding to the second series, okay, due to lengthened contraction. Electrode potential of copper is this, while that of the zinc is explained. 48. Higher ionization enthalpy of the to transform copper to aqueous is not balanced by the hydration enthalpy. However, because of the zinc after removal of electrons from the 4s orbital, stable 3D configuration is acquired. Halides of the transition element become much more covalent with the increasing oxidation state of the metal. As the oxidation state increases, the size of the ion of the transition element decreases. As per this ion rule, the size of the metal ion decreases, covalent character of the bond formed increases. The size of the metal ion decreases, covalent character increases. Ionic oxidation number of the metal increases, the ionic character decreases. Okay. While filling up the electrons in the atomic orbitals, the 4s orbital is filled before 3d orbital because of that n plus L rule, but reverse happening during the ionization of the atom. Explain why. During the ionization, 3d first, then 4s next, but while filling, 4s first, then 3d. Okay. Why? Filled as per n plus L rule, principal quantum number plus asymmetrical quantum number, but ionization 4s will be ionized first. Filled as per this rule. Okay, the 4s will be filled first because n plus L is 4. This is n plus L 5 here. So 4s then 3d. This is the way it is filled, but ionization enthalpy is responsible for ionization of the atom. Okay. 4s electron is loosely formed, so that will come out first than the 3d electrons. So this is the important thing. Okay. During filling up, during ionization, which comes first? Reactivity of the transition decreases almost regularly from this. Explain 51. Due to the regular increase in ionization enthalpy. Increase in ionization enthalpy, that means a decrease in reactivity. Okay, matching type. Match the items in the column 1, column 2. Okay, this is the catalyze, and which process uses this catalyze? Okay. Okay, this is in vegetable oil or to ghee. D, Sandmeyer's reaction. B, contact process. So these are all given in this book. Okay, 26. Haber process, Zinger catalyst. Okay, they are given here. Haber process, contact process. What are these? Okay, this is the contact process. Contact process. So you can go through it. Column 1, this compound, and what are the uses of these compounds? Okay, lanthanide oxide, a television screen. Okay, lanthanide, production of iron alloy. Okay, these things in 23. Okay, these are the uses of these various compounds. Match the properties given in property with the metal. Okay, an element which can show +8 oxidation state. Okay, this is the element osmium. So okay, these are the oxidation states. Third block element that can show up to +7 oxidation state. This one Mn. Okay, 2 to 7 more oxidation state for Mn. Third block Mn with highest melting point. Third block element with highest melting point. Okay, this one. See here, this is the one. This is the third block element. In this is the highest melting point. Match the following given column with the states, oxidation states. So you have to use those rules in the redox reactions chapter. They are given how to find the oxidation state of a compound. Okay, based on that if you use, and these answers will come. I have given the link to the video in the description. Column 1, column 2. Okay, solution and the color. Match the property in column 1 with the column 2. Properties. These 21. Okay. +4 oxidation state. +4 oxidation state. So they are given the oxidation states of the lanthanides, which are also showing +2, +4. So you can go through it. Okay, exhibit +4 state, these things. +2 this element. So everything is given on that page. Radioactive element, this one. Okay, match the properties given in the properties given column 2. Element with highest second ionization enthalpy. Okay, element with highest third ionization enthalpy. Ionization enthalpy. Okay, this is the ionization enthalpy. Second ionization enthalpy highest. This is the third ionization enthalpy. So here the copper and zinc. Okay, the Always second ionization enthalpy more than the first ionization enthalpy. Third ionization will be more than the second. Okay, I already told you. This is highest second ionization, highest third ionization enthalpy. So this M in this is this. This is correct. The iodide is not known. Okay, this iodide is not known. 12. Okay, here this iodide is not known. Except iodide, copper iodide is not known. Okay, because this oxidizes these two iodide ion. Oxidizes to this ion. Oxidizes this to iodine. Okay, this is correct. Assertion separation is difficult. This is correct because here is same group of the piano. This is correct, but it is not related. Okay, this is difficult because of the same physical chemical property, similar radius. Okay, so this is not the correct reason, but this reason is correct, not related to this. They are less stable compounds compared. This is not correct. Oxenoids are utilize their fire for okay. This is correct. Assertion. Cu cannot liberate. Okay, this is correct because of the less electrode potential. Because of the positive, this is also correct. The highest oxidation state of the osmium is plate said. This is correct. Osmium fire is correct, but this is not related to this highest oxidation state. Identify A to E, also explain the reactions. So this is, you can go through the answers. 64. Okay, here they are given these reactions. Okay, this also you can go through the answer. On the basis of the Leonard, explain the following: nature of the bonding in this 21. Okay, these oxidation states and how the bond varies, these things. Okay, in this graph, how the atomic number, how the radius varies, the how the bond formation differs. Okay, everything is given here. Okay, here they are given. Answer the following questions. What is the element of the first transition state, highest second ionization enthalpy? So this, okay, again the same table I already show you. First, second, third. First will be less than the second will be less than the third, and these are the highest second and third ionization enthalpies. Mention the type of the compounds formed when is small atoms like this is industrial compounds. Crystal, okay. See the compounds. Okay, you can go through these properties and these compounds. characteristics. This is these processes are given, already given the question number 52. Question number 52. See, this process already given here, so you can go through it. '71. So this also you can go through the answers. Okay. The important thing here, you understand how to find the oxidation state of the various elements in the compound, the separate element and ionized elements. Okay, from your class 11 redox reactions.